and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 7, Lesson 7, More Work with Rates. All right, so in the last lesson, we introduced the idea of how to convert a ratio into what's known as a unit rate. And we're going to be just working with that a bunch today. So let's jump right into it, into our first problem where we're going to review many of the important ideas from the last lesson. All right, recall when we divide the two numbers involved in a ratio, we produce a unit rate. And this idea that we're getting how much of one quantity per one unit of the other quantity. And let's kind of take a look at a little bit of a tricky one maybe in the first exercise. A recipe calls for 4 cups of flour and 2 cups of sugar. Answer the following questions based on this information. Letter A, state the ratio of flour to sugar in this recipe as a unit rate. Show the division/fraction and use appropriate per units in your answer. All right, so let's do this together. Now, remember, right, we want the ratio of flour to sugar, all right? So what we're going to do is we're going to say, well, we've got 4 cups flour per 2 cups sugar. All right. Now, whenever you do this, I really recommend having these units sitting there. Not just 4 divided by 2, but literally 4 cups of flour divided by 2 cups of sugar. Right? Now, at that point, I really want you to look at this. Now, here, we can really think of this as just 4 divided by 2. We could also think about it as the fraction 4 halves, but first and foremost, I want to think of it in terms of division, 4 divided by 2. And of course, 4 divided by 2 is just equal to 2. But what are the units? Well, the units will always then be the units of the numerator, 2 cups of flour per cup of sugar. All right, 2 cups of flour per cup of sugar. And we could say 2 cups of flour per 1 cup of sugar, but when we just say per cup, well, then that makes sense because now if I had, let's say, 5 cups of sugar, I would need 5 times 2, 10 cups of flour. Now let's look at the ratio in the other way. Letter B. State the ratio of sugar to flour in this recipe as a unit rate. Show the division/fraction and use appropriate per units in your answer. So it seems like we're almost answering exactly the same question, except the difference here is that we want the ratio of the sugar to flour. So in this case, what we're going to have is we're going to have 2 cups of sugar to 4 cups of flour. I have to write a little bit smaller now. Now, again, here it's a little bit trickier because now you're looking at this, which is truly 2 divided by 4. But we can also think about it as the fraction 2/4, in which case we want to just reduce it, right? And of course, 2/4 reduces down to the very simple fraction 1/2. Now, 1/2 what? 1/2 cup of sugar. We don't really want to say 1/2 cups of sugar, although I suppose we could. 1/2 cup of sugar per cup of flour, right? These two pieces of information really are telling you the same thing, right? They're really telling you that you need twice as many cups of flour as sugar or half as many cups of sugar than what you have of flour, right? But, you know, we have to be kind of ready for unit rates that could turn out to be nice whole numbers or fractions or what have you. But either way, we're always doing the numerator divided by the denominator so that we get how many or how much of the numerator per 1 unit of the denominator. All right, let's keep working with the idea of unit rates. So, ratios and rates. If two quantities, call them capital A and capital B, are in the ratio of A to B, then they have a unit rate of A divided by B, or the fraction A-beeths. Well, that really didn't sound right. With units of A per 1 unit of B. Yeah, you can't really do that with that fraction. All right, so let's just keep working with this idea of setting up a ratio with units and then converting that ratio into a unit rate that we can think about. Exercise number 2. Esme is making costumes for a play her middle school is performing. She buys 4 yards of fabric for $18. What is the unit price of fabric in terms of dollars per yard? Show your work. So we talked a little bit about unit prices or unit costs in the last lesson, right? And it's one of the most common examples of a unit rate, and it's really simple, right? We take, the ratio of how much we spent divided by how much we actually bought. So in this case, what that means is it means we would have $18 per 4 yards of fabric. All right. Now this one's a little bit annoying because 18 is not nicely divisible by 4, so I'm going to kind of do that division right over here. Let's figure out what 18 divided by 4 is. Of course, 4 goes into 18 4 times, but that leaves me with 16, and I subtract, and I get 2, and I drop a 0. So 4 goes into 25 times, and that gives me 20, and subtract and get 0. So 18 divided by 4 is 4.5. Now, let's talk about 4.5 what though, right? Remember, every unit rate is going to have the units of this, and I'll put these right here, per one of these. Now that's a little bit weird, $4.5 per yard. You could do it that way, but we are talking about dollars and cents, so it probably makes more sense, literally, no pun intended, to write it that way. $4.50 per yard, right? A great example of a unit rate and one that hopefully makes a lot of sense to you. If I went out and I bought, 4 hamburgers for $20, then I spent $5 per hamburger, right? It's super duper easy, literally the definition of division. Now let's take a look at letter B. If Esme buys 7 additional yards of fabric at the same cost, how much will she spend? Show your work. Well, again, this is what's so great about a unit cost, right? Or a unit price, is that I now have $4.50 for 1 yard, right? And I'm really multiplying that now by 7 yards, all right? In which case the yard unit actually cancels and all I'm left with is money. Now I gotta figure out what 450 times 7 is, and I've kind of run out of space, so I'm gonna do that down here. So we'll just do 450 times 7, 0, 5, 3, 28, 31. So it looks like Esme spends an additional $31.50 on those 7 additional yards of fabric. All right, so maybe we'll just circle this and go like that. Give ourselves a little bit of extra space there. Let's take a look at letter C. Esme's friend Cora buys 6 yards of fabric and pays $31.50 for it. That's ironically the same amount. Is the fabric Cora buys more or less expensive per yard than what Esme bought? Justify. All right, well, we know that what Esme bought was $4.50 per yard. We know that Cora bought 6 yards at $31.50, right? So we want to see which one had sort of the higher unit cost or the higher unit price. So what I'd like you to do is pause the video now and figure out how much Cora is paying per yard for the fabric that she bought. Take a moment to do that. All right, well, let's do it. So Cora, right, pays $31.50 per 6 yards. All right, in which case what we're going to do is we're going to want to do that division, and maybe we'll come over here to $31.50, divide by 6, and let's see, we got 5, 30, 15, 6 goes into 15 2 times, that's going to give me 12, subtract, I get 30, I'm going to go in there 5 times, subtract and get 0. So Cora is paying $5.25 per yard, which means Cora's is more expensive, right? She's paying $5.25 per yard, whereas Esme was only paying $4.50 per yard, right? And that's important because it's hard to compare sort of when you just are looking at the overall cost that people spend for things. If you really want to know how much they cost kind of relative to one another, then what you really want to see is how much do they cost per yard or per hamburger or per whatever, right? If I buy $30 of gasoline from one gas station and I buy $20 of gasoline from another station, I can't really tell you which gas station had the lower price unless I first figure out how much I spent per gallon, not overall how much I spent. All right, let's keep moving along on this. So unit prices, or how much one item of something costs, are an excellent and common example of a unit rate. All right, one of my favorite examples is sort of when you buy raffle tickets. So let's take a look at that in exercise number 3. A local charity is selling raffle tickets. They want to encourage people to buy more than one raffle ticket, so they advertise the prices shown below. All right, now let's talk about the prices a little bit. So you might go up to a raffle, right? And you'd say, oh, if you buy one ticket, you pay $3. If you buy 4 tickets, you pay $10, and if you buy 10 tickets, you pay $20, all right? And they do that because they want you to buy more tickets, right? But, you know, what's the best deal? Well, let's take a look at that in letter A. If a person buys only one ticket, then the unit price per ticket is clearly $3. What are the unit prices per ticket if a person buys 4 and 10? Show the calculations you used. All right, so let's just be very clear. If I buy one ticket for $3, the unit price is $3 per ticket, right? That's just the deal. I have one ticket, I spent $3. But what if I buy 4 tickets, right? Well, in that case, right, if I want to know what my unit cost is, then what I'm going to do is I'm going to be looking at $10 per 4 tickets, right? Now, in order to do that, I might, again, need to come over to the side of my paper. I might also be able to just do this in my head, but I might have to divide 10 by 4, in which case I'm going to get 2, 8, 2, 5, 20, subtracting 0. I'll throw another one on there. So that's going to be $2.50 per ticket. All right. So if I buy 4 tickets, right, it's a better deal per ticket than 1, right? 1 ticket costs me $3, but if I buy 4 tickets, I get them now at $2.50 per ticket. Now the 10 ticket unit price, that one's pretty easy. So pause the video now and figure out how much I'm paying per ticket in that case. All right, well, let's set up the ratio just to make sure we have it, right? At 10 tickets, right, I'm going to spend $20, on hopefully not 1 ticket, on 10 tickets. And now it's easy because 20 divided by 10 is a nice number, right? I don't have to do any kind of real work here. That's just $2 per ticket. And again, this is oftentimes the way things work, which is that the more raffle tickets you buy, the better the deal they're giving you, right? So, I mean, I'm spending $3 per ticket if I only buy 1 at a time, but if I buy 10 at a time, I'm spending $2 per ticket. I'm getting a much better deal. And speaking of which, then, let's take a look at letter C. If 20 friends want to each buy a raffle ticket, how much money will they save if they buy them in sets of 10 instead of 20 individual tickets? Show how you found your answer. All right, so this is important, right? Because let me just kind of go back up to that price a little bit, right? If we have these 20 people, they all want a raffle ticket, So if they each walk up there and, oh, here's my $3, they get a raffle ticket. Here's my $3, they get a raffle ticket. They're going to spend a certain amount of money. On the other hand, they could pool all their money, give it to one person and say, hey man, why don't you go up and buy us 20 tickets in these groups of 10, right? And then we'll just kind of divvy out the tickets between us. How much money will that save? Well, pause the video now and figure out how much money they save by buying at this rate rather than at this rate. All right, well, at the single ticket rate, right, then you'd have 20, right, times $3 per ticket. And it's really 20 tickets. And of course, that gives me 20 times 3, which is $60. On the other hand, right, at the bulk rate, right, if you buy 20 tickets and you're spending $2 per ticket, then you only spend $40, which means we will save $20. Now, it should be pretty obvious that we would save $20. In fact, we probably could have even skipped both of these calculations just by knowing that, look, if you buy your tickets individually, they cost $3 per ticket. If you buy them in groups of 10, they cost $2 per ticket, so they cost $1 more per ticket if you buy them individually than if you buy them in groups of 10. So if I buy 20 tickets, I'm gonna save $20 by buying them at this rate than if I buy them at that rate. All right, and again, it's a really good example. There's other things in the real world where if you buy more of them, the person who's selling it to you will actually drop the price per item depending on how many you buy to give you an incentive, to give you a reason, a motivation to buy more of something. All right, let's keep going. Let's take a look at one last problem. Now, one of the really important unit rates that we saw last time was speed. And remember, speed is simply the unit rate that comes from dividing the distance an object has traveled by the time it's been traveling. So let's take a look at exercise number 4. Kirk, who's that crazy guy? Kirk is driving on the Cross Island Parkway. He travels 70 miles in 2 hours. Letter A asks us, what is Kirk's unit speed in miles per hour? Show the calculation you use. All right, well remember, speed is simply going to be the ratio of distance divided by time. So pause the video now and figure out how far Kirk has driven in just 1 hour. All right, well I always like to see that ratio in fraction form. So we're going to have 70 miles divided by 2 hours. All right, and again, if you can do 70 divided by 2 in your head, awesome. If not, you come over here and yeah, we get this, subtract 1, 0, 5, 0, subtract, there we go. And that's going to be 35 miles per hour. Not very fast, but if you've ever been on the Cross Island Parkway, or really any kind of road on Long Island, this may seem like quite a fast speed to you. Anyway, so 35 miles per hour. And again, that's great because it means every hour we know the additional distance that Kirk has driven. All right, I'm a slow driver. That's just all there is to it. And we can now use that to fill this table in. Let's take a look at letter B. Fill out the table below with the distances that Kirk would drive at this speed and then plot on the grid provided. Wow, this is actually quite easy, right? And we're back to like ratio tables, right? So, I mean, obviously if Kirk hasn't been driving at all, then he's gone no distance. But in 1 hour, we now know exactly how far he's driven. He drives 35 miles, right? Every 1 hour, he drives 35. And in fact, one of the ways that we can fill out this table is just continually add another 35 to the previous distance we've driven. So if I've got, 70 plus 35, that would give me 105 miles. Then if I had 105 plus 35, that would give me 140 miles. And if I had 140 plus 35, that would give me 175 miles. All right. By the way, one thing that I'd hope you'd notice about this table is that in 2 hours, we've driven 70 miles. And if we double that in 4 hours, we've driven 140 miles, right? And you always see those kind of patterns when you look at ratio tables. Now we also want to plot this, all right, because I want you to see these plots of these constant ratio relationships, and it's kind of nice, right? So in 0 hours, we've gone 0 miles. In 1 hour, we've gone 35 miles. That's a little bit tricky. The y-axis is scaled in tens, not fives. So we have to think maybe a little bit about where 35 would be. 2 hours is a little bit easier. That would be 70 miles. 3 hours, 105, again, just to be a little careful there. 4 hours, we've got 140. That one's pretty easy. And in 5 hours, we have 175, which would be right there. And like all of these plots, the points lie in a straight line. And again, just as a reminder why they lie in a straight line, literally what we're doing on every situation is we're going 1 hour to the left and 35 miles up. Then 1 hour to the left, an additional 35 miles, 1 hour to the left, 35 miles, etc. Right? So we get this nice straight line. Okay, let's wrap this thing up. Right, so we really didn't do anything new today. What we reviewed was this really important idea that if you have a ratio written in fraction form, and then you express that ratio by actually doing the division that the fraction represents, the numerator divided by the denominator, you get a rate, a unit rate. How much of the numerator you get per 1 unit of the denominator. You can then use that unit rate for a variety of different things that you might need in the problem. All right, we'll work a little bit more with rates in the next lesson when we start to look at converting between different types of units, right? Different length units, volume, mass, etc. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.